Now let's look at speed and velocity. Now velocity is the rate at which the displacement of an object changes with respect to time. Now because displacement is a vector quantity, velocity is a vector quantity. So it has both magnitude and direction. In contrast, speed is the scalar quantity. It's the magnitude of velocity. Now to work out these things, average velocity, change in position over time taken, and our change in position is our displacement. Average speed is just distance travelled over time taken. So let's look at an example. If each of the 3 legs of Harrison's journey from the previous example took a total of 1 hour, calculate Harrison's average speed and average velocity for the whole journey. Express your answer in meters per second. So average speed is equal to distance travelled over time taken. Now in the previous example, our distance travelled was 23 kilometres, and our time taken, if it's an hour for each leg, we've got 3 legs, so that's 3 hours. Now the question says to answer in meters per second, so I'm going to change to meters and seconds now. So our 23 kilometres, we're going to have to times that by 1,000 to get it into meters. And our 3 hours, we're going to have to times that by 60 to get it into minutes, and times by 60 again to get it into seconds. So that's 23,000 meters over 10,800 seconds. Go to your calculator and work that out. It's approximately 2.13 meters per second, which you can also write as 2.13 meters per second to the -1. If you haven't seen that before, meters per second, and just using your index laws, you bring the seconds up and change it to a negative power. Now average velocity, which is displacement over time. Now displacement from the previous question is of course a vector, so 9I plus 10J. Our time was 3 hours, and that's going to be in kilometers per hour. So this becomes 3I plus 10 over 3J kilometers per hour. So our magnitude is the square root of 3 squared plus 10 over 3 all squared, which is approximately 4.48 kilometers per hour. Now to convert to meters per second, we've got 4.48 kilometers in 1 hour. Do what I did before, times by 1,000 at the top, times by 60, times by 60 at the bottom, and you get approximately 1.25 meters per second. Now the direction will be the same as the displacement. And thankfully I worked out the direction before, even though I didn't do it. Let's finish with the therefore statement. So therefore Harrison's average speed is approximately 2.13 meters per second, and his average velocity is approximately 1.25 meters per second at a bearing of approximately 42 degrees true.